So here we have some more examples for coefficients of friction and forces of friction. Suppose you are pushing on a 25 kilogram crate with 120 newtons of force, but it's not moving. The coefficient of static friction is 0.60 and the coefficient of kinetic friction is 0.50. What is the force of friction acting on the crate? Now this is kind of a trick question. Mostly because it gives you more information than what you really need. Really the only thing you need to know is that we're applying 120 Newton force, but it's not moving, meaning it's not accelerating. If it's not accelerating, that means the net force is going to be equal to 0. If the net force is 0, then that means the forces are balanced. So the force that I'm pushing on it with 120 newtons, guess what? Force of friction has to be equal to 120 newtons also. So because the free body diagram where the net force in the x direction is going to be equal to 0 because it's balanced, then that means that the force of friction subtracted from 120 is going to be equal to 0. We'll take that to the other side. The force of friction is going to be 120. Now if you actually calculated this out, you would figure out that if you use static friction because it's not sliding, you would multiply this and you would get 147 newtons. But that is the maximum amount of static friction. That's not what force of friction is actually going to be equal to. The force of friction is less than or equal to that maximum amount of 147. So it can be equal to 120 newtons. If I push on it with 120 newtons, it pushes back with 120 newtons. I push on it with 140 newtons, it pushes back with 140 newtons. All the way up until that maximum amount of 147 newtons. So we have the same scenario. Suppose we're pushing on the crate and the coefficients of friction are still static friction is 0.6, coefficient of kinetic friction is 0.5. So what minimum force would be needed to get it to start moving? Well, that would mean that I would need to find the maximum amount of static friction in order to do that. So the maximum amount of static friction is going to be coefficient of static friction times normal force, and we got to find the normal force. So we look at the net force in the y direction. Net force in the y direction equals mass times acceleration in the y direction. We got a downward force of gravity, so it's going to be negative. We got an upward force of normal force, so it's positive. That's going to be equal to mass times acceleration. Well, it's moving horizontally. It's not going to be moving vertically, so there's no acceleration vertically. We go ahead and plug this in. The mass times gravity is going to be the force of gravity, and we get 25 times 9.8. Take that to the other side. We get 245 newtons for the normal force. Plug that in for the normal force on the other side. Multiply that by 0.6 and we figure out the maximum amount of friction is going to be 147 newtons. So that has to be the amount of friction that we have to apply. That has to be the force that we need to apply in order to get the object to slide. So the net force has to be greater. The net force has to be greater than 0. So if I take force 1, I subtract the maximum amount of static friction, I need something greater than 0. So that means force 1 has to be at least greater than 147 newtons. And that'll get it to start to slide. All right, so let's suppose that we are now we've now applied that minimum force. We've applied 147 newtons to get it to start moving. So what would the acceleration be if we continue to push with 147 newtons, that minimum amount? So we got our force 1, which is 147 newtons. That's how much we got it to get it to start moving, and that's how much we're going to continue to apply. So the net force in the x direction is going to be equal to mass times acceleration in the x direction. That's how we find our acceleration here. We got force 1 forward minus the force of friction backwards, so negative force of friction, positive force 1. That's going to be equal to mass times acceleration. Well, we know force 1, that's going to be 147, but the coefficient of friction times normal force helps us define the force of friction because we don't know what the force of friction is. When we have static friction, when it's not sliding, the maximum amount was 147 newtons. But kinetic friction is always less than or equal to static friction. So when we get it to start to slide, it's most likely going to have less friction because kinetic friction is usually less. So in order to figure out the force of friction, we do coefficient of kinetic friction times normal force. So that's 0.5 times the normal force, which we found to be 245 on the previous slide. Then we get that the force of friction is going to be 122.5 newtons. We plug that into our equation. We plug in the force of friction, we plug in force 1, we plug in the mass, and then we solve to find the acceleration, and we get that the acceleration is going to be equal to 0.98 meters per second squared. And that's in the positive direction because our forward force is going to be greater than our backward force. So we apply that 147 to get it to start to slide, but if we continue to push with that minimum amount of static friction to get it to start to slide, then that means it's going to take it's going to cause it to accelerate because kinetic friction is always less. In this example, we have a 1.5 kilogram box that's being pulled by a force of 10.2 newtons, and it has an acceleration of 0.40 meters per second squared. So the question is, what is the coefficient of kinetic friction in this example? So we know that it's sliding because it is moving and it is accelerating. So the first step is for us to draw our free body diagram. The forces that are being applied, we know that it's going to have a force of gravity pulling down. We know that it has a normal force upward because it's in contact with this surface right here. We have a force of tension that's pulling it forward, but we also have some friction which is pulling it back. So our free body diagram looks like this. And our acceleration is going to be forward, so the forward force of tension is going to be greater than the backward force of friction. All right, so we do Newton's second law in the y direction because we need to figure out the normal force. And we also need to figure out the force of friction. In order to find the coefficient of friction, the equation is going to be force of friction equals coefficient of friction times normal force. So we've got to figure out the normal force and the force of friction first. Normal force, we use the y direction. Since there's no acceleration in the y direction, that means that the net force is going to be 0 in the y direction. We go ahead and figure out our forces in the y direction. Normal force is upward, the force of gravity is downward. So normal force is going to be positive, and the force of gravity is going to be negative, and that's going to be equal to 0. We have an equation for force of gravity. It's mass times the acceleration due to gravity, so it's going to be 1.5 times 9.8. And then we figure that out is 14.7. That's going to be negative over here. We take that to the other side, it becomes a positive 14.7. So the normal force is going to be 14.7 newtons. For the for the x direction, the net force is going to be equal to mass times acceleration also. Now, for this direction, we do have an acceleration, so we need to include that. It's not going to be 0 like it was in the y direction. Now we're going to put that into our equation. In the x direction, we have a force of tension forward, so that's going to be positive. We have force of friction backwards, so that's going to be negative. So the tension being forward, positive. Backward force of friction, that's going to be negative. And that's going to be equal to mass times acceleration. Plug in the numbers. We know the force of tension is given to be 10.2. We know that the mass is going to be 1.5 kilograms as indicated at the beginning, and then the acceleration 0.4 because that was indicated as well. We solve this. We do 1.5 times 0.4, and then we take the 10.2 to the other side, and we get our force of friction is going to be a positive 9.6 newtons. Now that brings us to our next part where we actually plug in our force of friction. We plug in our normal force, and that's going to give us our coefficient of friction. If we solve for coefficient of friction, we're going to take the force of friction and divide by normal force. So force of friction divided by normal force is 9.6 divided by 14.7, and we get a coefficient of friction of 0.65. It's not going to be negative, and it's not going to have units. Coefficients don't have units. If you look at the forces here, we got force of friction over normal force has newtons divided by newtons. That gives us no units, and then it's not going to have a negative because it's never going to have a direction. All right, so this next example, we are accelerating a crate. Now we're pulling on this crate at an angle of 20 degrees. Now when we draw our free body diagram, this force 1, this force of tension that's being pulled is now at an angle. So we have actually an upward component and a horizontal component to this. The upward component is actually going to decrease the amount of normal force needed because this upward force means that the normal force has to be less in order to balance out the force of gravity. So we're going to have less normal force. All right, so to figure out the normal force, let's see, what's the acceleration of the crate? So we've got to figure out the acceleration horizontally. But before we can do that, we have to figure out what that force of friction is going to be. So in order to find the force of friction, we've got to find that normal force first. So net force in the y direction equals mass times acceleration. There's no vertical acceleration, so we plug in our forces. We've got normal force upward, we've got force of gravity downward, and then we have the upward component of force of tension. That's going to be the sine of the angle. And that's in the upward direction, so it's going to be positive. Well, we're going to head and plug in what we know. We know that force of tension is given to be 17.8. The angle is 20 degrees. The force of gravity is mass times the acceleration due to gravity. So it's 2.4, which is the mass, times the acceleration due to gravity, 9.8. We go ahead and plug that in. We figure out our normal force is 17.4 newtons. Now, so will it accelerate? That's the next question. We're trying to find the acceleration, but since it's not sliding yet, then we need to figure out if it's actually going to accelerate. Is force of tension horizontal? Is this force horizontal actually enough to get it to start to slide? So we have to figure out what the net force is going to be in the x direction. If it's greater than 0, then yeah, it's going to start to slide. If it's less than 0, then force of friction static is just going to apply enough to balance it. So it's not going to be a negative acceleration. Force of friction is not going to cause it to slide backwards, but it is going to balance it out, so it's going to be up to that maximum amount. So if we do the net force in the x direction, we figure out that the force of tension cosine of the angle is going to minus the force of friction maximum, the maximum amount of static friction. That'll give us the net force in the x direction. Again, if it's positive, it's going to accelerate. If it's negative or 0, it's not going to accelerate. Everything's going to be balanced. So the force of tension, we plug that in, the angle, we plug that in, and the coefficient of static friction times normal force. Well, we just found the normal force, so let's go ahead and plug that in. That gives me 0.45, that's coefficient of static friction, times normal force, which is 17.4, and cosine of 20 times 17.8 gives me 16.7. So we calculate this and we get 8.9 newtons. Now, since the net force is positive, then that means it will accelerate. That means we have more than enough force horizontally from the tension in order to overcome that static friction. So now the question comes in is, what is the acceleration going to be? Since we know we have a net force that's large enough to get it to start sliding, then that means we're going to go from non-sliding friction over into sliding friction. Non-sliding friction was your static friction, that was the 0.45 times the normal force. Kinetic friction is 0.35 times the normal force, and since we know we have enough force to actually start sliding, that means our force of friction is going to decrease also. So we have to figure out what our net force is going to be, because it's going to change from static friction to kinetic friction. So we put in our force of tension cosine of 20 degrees, because that's that horizontal component of the force and tension, minus the force of friction going in the opposite direction. Now we're going to be using the coefficient of kinetic friction times normal force. Normal force we already found to be 17.4. So we plug that 17.8 cosine of 20 degrees, and that was 16.7. Subtract the coefficient of kinetic friction, which is 0.35 times 17.4, and that's going to be equal to our mass, which is 2.4 times acceleration. Figure out this side of the equation. We figure out that we got 10.6. That's a net force of 10.6, and you can see that that's actually going to be greater than the amount of net force that we had before. And the reason we have more net force now is because our friction decreased, and since our friction decreased, then our total net force is going to increase. Now we have more force forward than we have backward than we did before, so we have a greater net force. We divide both sides by 2.4, and we find that our acceleration is going to be 4.42 meters per second squared.